Okay, so we spent an extra day yesterday dealing with fractions, and we did the tool size worksheet just to get a little extra practice with them. Today we're going to move on to the next step. We've already looked at our place values to the left side of the decimal point. Now we've got ones, tens, hundreds, 1,000s, and so on. I'm just going to put them in as numbers here. What we notice there is every time we move one place to the right, our place value is divided by 10. One place to the right, we divide by 10. And so on. So, if we were to keep moving to the right, we would keep dividing by 10. So what's 1 divided by 10? 1/10. Divide by 10 again, 1/100th. 1/1000th. 1/10,000th. Bless you. This also explains, by the way, why there's a ones place on one side of the decimal point and no once place on the other side, because we're dividing by 10. Now, as you look at those place values, you might be thinking, those look suspiciously like fractions. And it's the truth. They are fractions. Now, what decimals are is nothing more than just a short way of writing fractions with common denominators that are powers of 10. So if I have 0.34, that is just a shortcut way of writing 34/100ths. In fact, that's how we would pronounce that, is 34/100ths. And it really is that easy to convert a decimal into a fraction. Of course, I would reduce that. Both of those would be divided by 2 to give me 17/50ths. Or we might have 0.0375. How would I pronounce that?
375 10,000.
Perfect, 375 10,000ths. So that is how it's going to be written as a fraction. How do I know that it's 10,000ths and not hundredths or thousandths? Well, it's the place value of the last digit is what its name is. And it's tens, hundredths, thousandths, 10,000ths. Another way, a shortcut of remembering. I hate shortcuts, but I'll give you this one. 1, 2, 3, 4 decimal places. 1, 2, 3, 4 zeros in that denominator. Now, this isn't done yet. What would I want to do with this fraction? I could divide by 5, which is going to give me what? 75 over 2,000. Am I done? No, what can I do? Divide by 5 again, giving me 15 over 400. Divide by 5 one more time, giving me 3 over 80. Not so bad. What if it is 9.086? We'll go with that. What do we do with that number in front of the decimal point? Yeah, it's just a whole number. This is just like having 9 3/8 or 7 1/2. This is a mixed number. The part in front of the decimal point is just the whole number portion. That's not going to change. It's the part after the decimal point that becomes the fraction. So 0.086 is 86 thousandths. Again, 3 decimal places, 3 zeros. What am I going to do to that? Reduce it by 2. So 86 becomes 43. 1,000 becomes 500. Can I reduce that anymore? No, we can't. I got to remember to go put it back with the 9, though. 9 and 43 500ths. What do you think? Okay, well, You're asked to round to the nearest 10,000th. And you have that number. First of all, what digit is in the 10,000ths place? 6. We look at the next digit after that, which is 3. That tells us 2.8 or 2.5876. That's it. Oops, get back here. Let's say I have the number 7.439561. What digit is in my 10,000ths place? 5. What's next? 6 tells me round up, 4396. Now, you guys being in CNC, got to be a little careful in the machining industry. But that word, round to the nearest 10th. Mathematically, round to the nearest 10th means mathematically the nearest 10th, that's the 10th place, right? But in machining, you got to be careful because, like you said, a lot of times when they say 10th, they're talking about the 10th of 1,000th. They're near 10,000th. A 10th is a lot of times that digit there because you're always talking in thousandths in machining. So you have to be very careful with that language. Have you guys talked about that in the shop at all yet? Does that come up? Or?
It was in our book.
It was in your book? Okay. So in this case, when I say round to the nearest 10th, I am talking about to the mathematical 10th, to the 10th place value. So how would I round this to the nearest 10th? Well, what digit's in the 10th place? The 8. Next digit is 7, so 3.9. On this one, we're assuming we're in the shop. Round to the nearest 10th means I'm going to round to the 10,000ths. That's the 10,000ths place. What comes next? 2. So it's going to be just 7635. Okay. Just something to be aware of. Okay. Let's go through our operations with decimals. I know this shouldn't take long because your decimals are usually pretty good. If I have $2.736 plus 14.85. When I go to write this out, what do I have to make sure I do? Okay. Both of you are correct. Since this is thousandths and this is hundredths, I should put a 0 in there to make sure they both have 3 decimal places. 2 reasons for that. One is to give them the same name. The other is, we've always been taught you got to line up the decimal points. The reason we got to line up the decimal points is to give them the same name. So the 2 kind of go together. So that 0 there fills in. And now we add down our columns just like any other number. 6 and 0 is 6. 3 and 5, 8. 7 and 8, 15. Can I carry the 1 past the decimal point? Yeah, that decimal point affects absolutely nothing as far as how we add. The only thing the decimal point does, there's 2 things. 1, like we already said, you have to line it up before you start. And 2, as you're adding, before I can do my next column, what should I do? Bring my decimal point straight down. Why did I bring the decimal point straight down? When I add numbers, I keep the same name. These are tenths. This better be tenths. That decimal point has to stay in that same position. So we bring it straight down. These are ones. What goes here has to be 1. So my decimal point has to stay there. So 1 plus 2 is 3 plus 4 is 7. Now we bring down the 1. So 17.586. So let's take something like 23.4 times or plus 0.7963. Tell me what to do. Decimal point, okay. 7963. I really should fill in zeros. And then, so this is 3, 6, 9, 11. So 1 carry the 1. Before I can do the 1 and 3 and 0, I need to drop the decimal point. 1, 3, 0. 4 and 2. Good. Now I realize decimals work really easy on the calculator. So I'm assuming there's a good chance you're going to use the calculator. But anybody want to guess what statistically one of the first 2 or 3 keys to start malfunctioning on most calculators is? The decimal point. It is one of the first keys. I don't know why, but for some reason, statistically, one of the first keys to malfunction is the decimal point. Yeah? That's always wonderful when you're in the middle of a test and the calculator says, I'm out of here. Did you take it home and like smash it or something? Just.
I don't know. I noticed I brought it up to work too, and I pressed the button and it didn't go right away.
Is it a solar or is it battery?
It's cold.
Okay.
So I don't know why.
So it's not like the batteries can be dead or anything like
I think I just had a jump.
that. Okay. I know a lot of times with the battery ones, when the batteries get really low, they start to do some really funny things. Solar, you might try taking it out in the sunlight or something and see if that has an effect. Sometimes the lights aren't bright enough.
These lights are bright enough.
And they still.
They were really, really bright in there. I just didn't want to do anything.
Huh. Interesting. So anyway, I tell you, you have no idea how many times I've shown up on a job. I used to do construction as a structural engineer, and I did a lot of job site visits. No idea how many times I showed up on a job site and I'd throw my calculator up in the dashboard of the truck, and it was wrinkled in the sun and it didn't quite work, or the screen was black because it got hot enough to burst the crystals in it, or got dropped in the sand and like 3 keys stopped working. You'll learn to do it without the calculator real fast. So yeah, something like this. Hoping you're looking at that saying, hey, this is about 1. So 1 to 23 is going to be 24. Decimals are a little bit tougher to estimate with because they're going to be smaller. We can't round this off all the way to be 20, because if we're rounding that to 20, then we're losing something here. But the other thing you can look at is you see that this is smaller than 1, so your answer is going to be really close to whatever this first number is. So it's a little bit trickier to do your estimating, but make sure, again, just like with the whole numbers, you're looking at it and you're giving yourself some idea of what you expect this to be. Because if I punch this in the calculator and I get something like, what happened there? Well, I added, yeah. This decimal point didn't register. So instead of 23.4, it went as 234. Calculator added it correctly for what I entered, but that's not what the problem is. So be very careful with that. The decimals can really, and usually it's really easy to catch a mistake with decimals because it'll be off by something ridiculous like that. Subtraction with our decimals. Something like this. When I set this up, what do I have to be sure to do now? Line up the decimal points again. Now with addition, it was optional. It was just considered good form to fill in the zeros. Here, I really don't have a choice. I have to fill in the 0 or nothing's going to work. Now what do?
Take away 1 from 7.
Perfect. 0 minus 3 isn't going to work, so I got to borrow from the 7. That's 6, and this becomes 10. So now, 10 minus 3 is 7. 6 minus 4 is 2. 5 minus 6, borrow from the 7, and that's a 6 is a 15. The decimal point does not affect our borrowing at all either. All the decimal point does is it has to come straight down. Does not affect carrying or borrowing. 15 minus 6 is 9. Bring the decimal down. 6 minus 2 is 4, and 1 minus 1 is 0, so we don't have to worry about it. Now, we're not going to do a lot of examples of subtraction because it's not terribly difficult, but I do want to do something like this. First of all, when I go to set this up, where is the decimal point on the 38? Right after the 8. If there's no decimal point in the number, it's at the end of the number. So then I got to make sure I line that up. 9.5627. And again, I'll fill in those missing zeros. This time I got 4 of them. Now I go to borrow. 0 minus 7, of course, can't be done. I go to borrow from this next digit, and there's nothing there. So what do?
Keep borrowing all the way.
I got to go all the way up here to the 8 is the first time I have a number.
Well, I'll just start from the 3 since you're going to have to leave again anyway.
Well, we'll do that in the next step. But we'll do it step by step. We'll start at the 8. This is now a 10. But I don't need it here. I need it way down here. So what do I have to do? I have to keep borrowing. This is a 9, and this is a 10. And then this is a 9, and this is a 10. One more time. This is a 9. This is a 10. So we have to borrow over and over until we get the value to where we need it. Now we can subtract 10 minus 7, 3, 9 minus 2, 7, 9 minus 6, 3, 9 minus 5. 7 minus 9, we got to borrow. This is 2 and 16. 16 minus, or 16. 17. Apparently I'm taking a commission off of that one. 17 minus 9 is 8. Then the 2 minus nothing is 2. 28. Now again, you look at this. This is about 38 minus about 10, so 28 makes sense. Same here. 18 minus 13, you're looking at something around 5. Keep those in mind as you're working with these. Multiplication. If I have 2.75 times 8.4. First of all, do I need to line up the decimal point? No, because when we multiply, we do not need the same name. How does the decimal point affect our multiplication? Well, just like addition and subtraction, it really doesn't. We ignore it. Exactly. When we're done, we have to put it in the right place. But until then, we don't care. So where do we start? 4 times 5 is 20, so 0. Carry the 2. 4 times 7, 28, plus 2 is 30, so 0. Carry the 3. 4 times 2 is 8, plus 3 is 11, so 1. Carry the 1. And then put a 0 here. 8 times 5 is 40, so 0. I always put a line across here when I move over to the next digit. So it's 0, carry the 4. I put it above the line so I know it's new. 8 times 7, 56, plus 4 is 60, so 0, carry the 6. 8 times 2, 16 plus 6, 22, so 2, carry the 2. 0, 0, 1, 3, 2. Where does my decimal point go? After the 3. Because We've been taught to count 1, 2, 3 decimal places in the problem. So we start at the end of the number and we count back. 1, 2, 3 decimal places in our answer. Be careful. Some people will look at that and say, oh, I don't need the zeros. And then they'll count their 3 decimal places. Don't do that. Those zeros have to be there until we place the decimal. So the debate is, do they need to stay there now? Well, at some point we're going to talk about something called significant digits. We'll talk a little bit about how you keep those. We're not going to get deep into them, but we are going to look at them for just a couple of days. For right now, they really don't tell us any information numerically. Sometimes in a measurement they will. Also, another method for placing that decimal point. If I look at this, this is how much? About 3 and about 8. What's 3 times 8? 24. So I would expect my answer to be close to 24. Does 231 make sense? No. Does 2.31 make sense? No. So the only place that makes sense to put that decimal point is right there. I'm going to have you guys try one without a calculator in your seat. Maybe try that one. Let's see how you did. Tell me what to do. Walk me through it. Okay, so 5 times 2. Okay. 4 times 2 is 8. So 2, carry the 1. 28, 29, 2. 2 zeros because we're moving over 2 spots. Good. Put another line there. 10, so 0, carry the 1. 15, 16, 35, 36. Okay. Okay, and decimal point goes 1, 2, 3, 1, 2, 3. Again, 7 times 50 is about 350. So 398 makes sense. 39 doesn't. 3,989 doesn't. Only place the decimal can go that makes sense. Dividing decimals. What's that? Oh, sure. Dividing decimals is one of the places where, again, just like all the other divisions we've seen, it has been changed and altered to the point where you don't even recognize it anymore. Remember back on the second day of class when I showed you the true long division? Well, for dividing by decimals, it's the same process. There's nothing to change. And I'm going to show you that first, but you don't have to put it in your notes because obviously I'm not going to expect you to do it that way. So let's say I got 74.562 and I want to divide it by 3.8. What's this first place value? Hundreds. 100 times 3.8 is 380. Can I subtract that? Say no. Wait, that's not the hundreds.
From 3 from the 7.
What am I doing here? Just a second. The 7 is not in the... 7 isn't in the hundreds place, it's in the tens place. 10 times 3.8 is 38. Can I subtract 38? Yes, I can. Can I do it twice? No, I can't. I can just subtract 38 once, which will give me 36 here. So what I did is I just subtracted the 3.8 10 times. Does that make sense? I'll bring down the 5. That's 36.5. Next place value is 1. Actually, I can bring down the 6 and the 2. It doesn't matter. 1 times 3.8 is 3.8. Can I subtract that? Yeah, probably 9 times, I would guess. 3.8 times 9 is going to be what? 34.2, right?
3.8 times 9.
3.8 times 9 is 34.2. So these are the 2.362. So I just subtracted it 9 more times. Next place value is the tenths. 0.1 times 3.8 is 0.38. I can subtract that several times. What, 5 or 6? Let's try 6. That's 2.28. So 280. 0.82 is what's left. I just subtracted it 6 times 0.1 or 0.6 times. Does that make sense? Next place value would be the hundredths. 0.01 times 3.8. 0.038. Can I subtract that? Yeah, twice. I'll do 0.076. 0.006 left over. We just subtracted that 2 times the hundredth. So 0.002. Oops, not 0.002, 0.02. And then we can keep going. Next place value would be 1,000. Times 3.8 is 0.0038. I can subtract that if I wanted to. And I can just keep going like that until I get to a point where I want to round it. So you can see here, this process of long division, if I learned it with whole numbers correctly, the way I showed you guys the first time, if we learned the real process of long division, dividing decimals is no different. It's exactly the same. But when we were doing our long division with whole numbers, when we were taught when we were kids, we shortened it up and abbreviated it to the point where it doesn't show the real process. So that when we got to decimals, we couldn't do decimals with long division anymore. The main reason was there was no way with that abbreviated form of long division, there's no way to locate the decimal point. When I do it this way, the decimal point locates itself. This is going to be 19.62 and then keep going if I keep going with it. So, but anyway, like I said, I'm not going to make you do it that way. I'm not going to change it. I just wanted you to see that the long division with decimals is exactly the same as long division with whole numbers if you do it the real way. But we've all been taught the shortcut. So let's look at that shortcut. So if I have 3.8 to 74.562, what have we been taught to do when we try to divide with decimals? We've been taught to do what? Yeah, position the decimal point so that we're not dividing by decimals. That means I got to take this decimal point and do that with it. Move it over. That means I have to do the same thing over here. So you said multiply by 10, and it's a good thing you bring that up. Why is it that we are allowed to move that decimal point? Because we've talked about this a little bit before. Fractions and division are really the same thing. A division problem can be made into a fraction can be made into a division problem. I can think of this as 74.562 over 3.8. And when I have a fraction, I can do this if I can multiply the top and bottom by the same thing. So if I multiply the bottom by 10 to make it 38 and get rid of the decimal point, I have to multiply the top by 10 to make it 745.62. But again, the shortcut we've been taught is that however many spots I move the decimal point here, I got to move the decimal point that many spots there. So this does become 745.62 divided by 38. Now what? Now it's just like our shortcut for long division before. Does 38 go into 7? No, so I'll leave it blank here. How about 74? 1 time, since the 4 is the last digit I use, the 1 goes above the 4. 38, I get 6.3. Now I can bring down the 5. 38 into 365 is 9. What is that? 342? What?
Same question.
Yep. You want to cheat and peek back at the previous answers, what you're saying?
Why not?
Well, I was gonna say,
It's already did the work just as well, right?
Like, we just did this one.
So we got 23 left over. Can I bring down the 6 now? Almost. What do I have to do before I bring down the 6?
Down the decimal.
Move up the decimal point. Very good. Then I bring down the 6. 38 and the 236. I believe it'll go in there 8 times. No, it won't. It'll go in there 6 times, though, I bet. $228. I had to borrow from this. This is a 2 and a 16. This is now just 8. Can I bring down the 2? Yep. 38 goes in there twice. That's 76. I've got 6 left over. Am I done? It could be, but I'm not sure. Let's say I want my answer. The nearest thousand. To keep going, I'd have to just put in a 0. And drop the 0. Now 60. Is 38 going to 60? Once. Very good. That'd be 38. 22 left over. Are we done now? We're at the 1,000th.
You gotta round to it.
We got to round to the nearest 1,000, so we got to go one more and bring down another 0. 38 into 220 is 5 times. 38 times 5 is 180. No, that's not right. 38 times 5 is 190, sorry. Which is 30 left over. The reason I had to go that extra digit here was because now that 5 tells me that this is not going to round to 19.621. It's going to be 19.622. Since that's a 5 or larger, this has to round up. Dividing with decimals by hand, I realize, is not a fun process. As I said with long division with whole numbers, it's a process I try to avoid if I can. But I'm going to have you guys try one in your seats just to see what you can do. Because I can. So 93.5643 divided by 4.25, and I want it to for the nearest 1,000. So where do we start? Perfect. So this is going to become 9,356.43 divided by 425. And then, is it going to the 9? Nope. 93? Nope. 935? Twice. So put the 2 above the 5 because that's the last digit we've used. 850. So that is 85 left over. Okay, and then 6 and 2. That goes above the 6 because that's the last digit we used. That's 850. And the 6. We got to bring the decimal point up. Very good. I didn't want the arrow down. I wanted it up. Then we bring down the 4. This is 64. That's 425 going to 64. No. Now before we can bring down the 3, we got to fill in a 0 above the 4 because we didn't use it. Or we used it, but we didn't do anything with it. Now we can bring down the 3 once. That's 425. $218. Are we done? Add digits. Add a 0 and drop it. 425 into 2180. 5 times, that's 2125. going to give us 55. All done now. We're at the thousandth. No, another 0. 425 into 550. 1. So this ends up rounding to 22.015. What do y'all think? Still better than a sharp stick in the eye?
Not by much.
Not by much? Better than fractions. Okay.
I'll take fractions.
This is easier to enter in the calculator when you need to, at least, right? In your little book, it will be units. Where are we? 11, 12, 13, and 14. Again, just do the odds. Check them back. I'll give you the last 5 minutes here in our first hour class to work on them, then we'll take a break. I'll probably start out by giving you a little bit of time at the beginning of the next hour to work on them too, just to get you a little chance. I've shorted you a little bit on homework time here this week.